I see those ridges start to go away, and I'm going to get a nice flat edge. My iron's starting to get warm, cold, so it's not going to melt my ice as well. That's okay, my ice is already warm. So take this and melt it down, and I take this and put it together and hold it for a minute. And it stays there. There's a little bit of adhesion, not much. Well, more than I thought. The block's colder than I thought. So we got that. See? It held on for a little bit, and mostly right here in the center, probably where the mass of the ice is colder. It wasn't holding on all the corners and edges, so I wasn't getting full freezing capability all around it. But you can see that one little spot, because that's the mass of the ice. That's where it was the coldest. Again, the same thing here. The mass of the ice is colder than the edges of the ice, so that's where it froze. That one little spot. Okay. Now let's just see how far I can go with this. We may use this in a minute here. Let's just see here. So we're going to clean that edge up again. You still got a little hole there. You may have to saw that. Thank you. When you put it in this warm water, that aluminum warms up real fast. The other advantage of warm water versus the clothes irons, it's a lot more efficient. Alright, so I got a nice, smooth, flat surface. I'm going to warm my iron up a little bit again. And I'm going to give myself a little room to work. We're just going to see how far we can push the limit. Okay? Now, in my cooler here, we've got our ice. What is that? We've got pieces of ice that I've got in here with some dry ice. Oops. And they're freezing together. So we got good contact. Good. All right, so we can see some thermal shock is starting to happen. Well, I'm going to have to be careful of that because I'm going to do just the opposite. Warm it up. So I'm going to take this, and I don't want to warm it up too much, just a little bit, because I want it to stay cold. Put that on there, and can you put some water in that little bottle for me? And if you see little gaps, pretty good contact, because you can see a little bit here, just a little bit of water. Okay? Now, just in that time, see, that's stronger than the other fuse was because I'm freezing, it's freezing in all the corners. This corner here is not freezing. I can see I'm not making real good contact there. All right? So I'm going to take my iron and I'm going to clean up the top of this. Water. Just put that in. All right, so we're going to get another piece. Okay. We're going to do that a bunch of times. In and out, in and out, in and out. Okay. All right. So I'm going to take this. I'm going to warm it up a little bit. I don't want to get it too warm because if I do, then I'm going to lose my cold and my adhesion. Won't happen. Let's kind of give it a little bit of an angle. We're just going to, like a pair of steps. And the more water you put on it, the more you, we're going to have trouble. Let me get another piece. see, what I could have done, which might have helped a lot, is if I would have done this step right here, and then put it in the freezer, when I come back to just what I would call glaze it, I wouldn't have to touch it for very long and it would stay warm. Now if I do, see, that's a good one there. If I do this all properly, there's enough water just in that process right there to fill the gap between these two blocks and freeze it together. Okay? And that's ideal. If you can utilize only that amount of water, then you're getting really good fusion and it's starting to hold together very well. And as you can see, when you come up maybe later, I'm getting an invisible seam. If I used a saw, you'd see all that sanding and all that saw marks in there. But here I get an invisible fuse and you get a lot clearer, cleaner product. Okay? Thank you. So let's take this. And see, every time I do this, I'm warming my ice up and I'm keeping it from freezing. So that's why, as I was talking before, if I would have prepared these surfaces and they were already smooth, I'd have less warming of this ice and better freezing capability. See immediately when I put this on where the holes are because they don't want to match up. Yeah, see, I'm not matching up here. Hang on, I think it's on this piece. Yeah, that's where it was. See, it freezes pretty quickly. You should get almost immediate adhesion. If your ice is cold enough and you've got both those edges making 100% contact, it should stick immediately. All right, I will. But I need room here. That's my problem. I need room. See, I can still see some ridges in here, so I'm going to hang out a second, let my metal get warm. And I need to take these ridges away. I can look at that and I can see my saw marks. Okay. See, there's good thermal shock right here. That piece of dry ice fell over and made contact. Now, when I try to smooth this out with this iron, I'm going to have fun. It's going to do one of those just the opposite direction. Then you can see how I can just stretch this out. I can just keep going to the point where this piece right here, I've got strength in here, and here, and here. Basically somewhere right in here, where I've got my thinnest part, is my weakest part. Okay? So the question starts to become, how much weight will this support? Okay? The only way you're going to find out is by playing around. Okay? You're in your shop or wherever you may be working, you're going to do something like this. Make sure you get good contact. Make sure you've got good contact. If you're looking at it and saying, well, that's not good contact, that's not good contact, that's not good contact, let's see how much weight it'll take. Well, it's probably not going to take hardly any. Okay, so you want to make sure the job's done right, so you know what the maximum amount of weight you can put on this. Okay? So we're going to go one more level. Short piece. Oh, we have a piece over there. This is cool. See, now what I'm starting to do, look what I'm starting to do. All of a sudden, I've got leverage. Here's the other thing to take into consideration. I've got leverage going, and this is probably 135 pounds, 140 pounds of ice, but yet I can move it. I could probably take this and pull it down because I have enough leverage, okay? So, from this point, it doesn't become so much the question of how much weight will my stair step and my fuses hold. It's, I've stretched it so far, the weight is more, the leverage is more than the weight holding it. Okay? So you have to be careful of that. So I may need your hand back here. Alright? So we're going to take our lovely lady and we're going to give her a little bit of clean up here. And we're just going to see if this will support it. Now that head probably weighs 9 pounds, 8, 10 pounds. And we'll have to get a scale and see. But you see, you can see how much weight that can support. Just hanging out there. So it's going to let up a little bit. See, if we've got more weight, can you let go at all? No, you can't let go at all. All right, he's got to hold on to that. There's more weight, and that's not a lot of weight. I mean, maybe 9 pounds. Each one of these sections is probably a pound and a half, 2 pounds, pound and a half. So let's say 2 pounds. 2, 4, 6, 8, 10. 10 pounds and a little bit there. Maybe 20 pounds of weight on there, and it's wanting to take a 130-pound piece of ice and flip it over. Just simply because I've got probably 30 inches extended out. Okay? So there's a lot of factors involved, a lot of physics and a lot of factors involved in ice. Now, one of the mistakes that happens to a lot of people, I mean, I'm sorry to say this, but I've crashed too many times and I've learned this the hard way. Vibration is a huge, huge enemy of ice sculptures. That's one of the things I have to take into consideration as far as